All right, everyone, so let's take a look at the review and preview problems of 1.2.6. All right, so this is going to be 5 problems, 114 through 118, and it says for each part below, find a giant 1 that will multiply the fraction on the left side of the equation to create the equivalent fraction on the right side of the equation. Then complete any other missing information. All right, so it just told us that the fraction on the left side of the equation is equal to the fraction on the right side of the equation, okay? So 5/6 is going to be equal to 15 over a missing number. And we're trying to figure out what that missing denominator is. So if the desired numerator is 15, then we have to figure out what we must multiply 5 by to get to that number. All right, so 5 multiplied by what number is going to give us 15? Well, I could do 15 divided by 5. I could work backwards to figure that out. And I find that the answer is 3. And so 5 times 3 is going to give me 15. So I have to do the same thing to the bottom, right, because our fraction is a big 1. And so my final answer would be 18. Right? 5 over 6 is equal to 5 over 18. So now we're moving on to part B. And again, we have this big 1. And remember, the big 1 is talking about like 9 over 9, 3 over 3, 2 over 2, right? It's a fraction that is equal to 1. So this fraction is equal to this fraction. So we had to multiply 3 by what to get to 6? Well, we'd have to multiply 3 by 2 to get to 6. And we do the same thing up top. But notice this time we are given our fraction on the right, 4 over 6. So we have to figure out what the numerator of our first fraction is, this one right here. Okay, so instead of multiplying by 2, we don't have that number yet, so we're going to have to divide 4 by 2. So if we do 4 divided by 2, that gives us 2. And so my missing numerator would be 2. So my fraction 2 over 3 is equal to 4 over 6. All right, moving on to part C. What over 2 is equal to 8 over 16? Okay, well, here I'd have to do 2 times 8 to get to 16. So I have to do the same thing up top. And I can work backwards here. I can do 8 divided by 8 will give me 1 as my numerator. All right, so my fraction would be 1 over 2 is equal to 8 over 16. Last problem here. What over 4 is equivalent to 6 over 24? All right, so I had to multiply my denominator by 6. 4 times 6 to get to 24. So I do the same thing up top here. So what multiplied by 6 would give me 6? Well, that would be 1. I'd do 1 times 6 to get 6. So my fraction 1 over 4 is equivalent to 6 over 24. All right, looks good there. So now we're moving on to 1-115. It says Fareed wants to add 1/4 plus 5 over 8. All right, so we're going to add the fractions by using a giant 1 to create a common denominator. Well, first I have to look at what the first, the common denominator here would be 8, right? 4 and 8 both go into 8, all right? And so I have to figure out 1 over 4 multiplied by what gets me to a number over 8. Well, I'd have to multiply 4 by 2 on the bottom to get to 8, so I have to multiply the top number by 2, and if I do that, it's going to give me 2. And so 1/4 is equal to 2 over 8. And then I have to add that to my other fraction, 5 over 8. And if I add 2 plus 5 on top, I'm going to get 7. And since we're adding fractions, we're going to keep the denominator the same. And my final answer would be 7 over 8. And that makes sense, right? If we had a spinner that was divided into eighths, and say 1/4 or 2/8 of those slices were red, and then 5/8 of the spinner was green, then we would have a probability of 7 over 8 of landing on red or green. Okay, so that's where adding fractions comes into play. And then part B says, how can factors help you find a common denominator? Well, we need to figure out what number both 4 and 8 go into. And so we could create a little list here. We could say 4, 8, 12, 16, and then if we started with 8, 16, and so on, and we'll notice that 8 would be called the least common multiple, or the smallest number that both 4 and 8 go into. And then finding that common denominator allows us to add straight across on top, right? We could just do 2 plus 5 on top, and then just keep our denominator the same on the bottom to arrive at our answer. All right, so that's how the common denominator being the same can help us. Next, we're looking at trying to go to the next problem here. (1-116) says Mario was visiting the carnival when he noticed a few number relationships. He made them into brain teasers for us. All right, if 3/10 of the visitors were adults and there were 100 visitors, how many visitors were adults? All right, so the fraction or the probability that we're given is 3 over 10, 3/10. That's how many were adults. Now we need to figure out how many adults there would be if there were 100 total visitors. All right, so what do we have to multiply 10 by to get to 100? Well, we could do 100 divided by 10, which would give us 10. And then we need to multiply the numerator by that same number, so 3 times 10, and that's going to give us 30. So of the 100 visitors, there would be 30 adults. All right, that is part A. And now we're looking at part B. 5/8 of the pizzas at Giant Spin were dolls. Oh, prizes. There, now we can read it. 5/8 of the prizes at the Giant Spin were dolls. If there were 64 prizes, how many prizes were not dolls? There's our key word, not dolls. All right, so I'm going to get rid of what we have here for that last problem. And this is going to be 2 steps, right? Because it gives us how many dolls there are, but we're looking for not dolls. So let's start off. 5/8 of the prizes were dolls. And so that means if 5/8 of the prizes were dolls, that 3/8 of the prizes were not dolls. Right? If we did 8 over 8 minus 5 over 8, it would give us 3 over 8. If you're not sure what I'm talking about, this is all of the prizes. And if 5 out of 8 were dolls, then that leaves us with 3 out of 8 that were not dolls. So that's where I'm getting this from. Okay. And then it says if there were 64 prizes, how many prizes were not dolls? All right, so here 3 over 8 is the fraction for not dolls. And now we need to set it equivalent to a fraction over 64. All right, and so here we can get from 8 to 64. by multiplying 8, right? You can do 64 divided by 8 to find that. And so we'd have to multiply our numerator by the same number, 8, and 3 times 8 is going to give us 24. And so our final answer would be 24 prizes were not dolls. So there it was 2 steps, but still wasn't too bad. Moving on to 117, order these numbers from least to greatest. All right, you'll notice we have fractions, decimals, and we need to put them from least to greatest. So what you could do to start off is make them all fractions, or you can make them all decimals. I'm going to keep them how they are, and I'm going to instead make a number line. So I'm going to look at what is my smallest number here, or my lowest number. Well, -2 would be on the negative side of the number line. I don't see any other numbers that are negative, so that would be my least greatest number. And then, see, my greatest number would be 2, I believe. Do I see anything greater than 2? I do not. So 2 is going to be over here on the other side. And that means 0 would be right in the center. So far I have 1, 2, 3 out of my 7 total options listed. And then I'm going to take a look at 1/2. Let's see, where would 1/2 be? Well, I know it would be on this positive side. And so let's first divide 0 and 2 into 1 in the middle. And if I was looking at 1/2, well, that would be right between 0 and 1. All right, so I have that one taken care of. And then 1.1, where would that be? Well, it's going to be close to 1, but it's a little bit greater than 1. And so it would be about right here, 1.1. And then we're looking at 5 over 3. Okay, so 5 over 3, if I were to put this into a mixed fraction, would be 1 2/3, right? Because it'd be 3 over 3 with 2/3 left over. And so if I go back over here to my line, I know it would be greater than 1, okay? And then it's going to be between 1 and 2, but 2/3, so it would be closer to 2. Think about if I divided 1 to 2 into thirds. So I have 1/3, and another third, and this would be my final third, okay? My 2/3 would be right here. Does that make sense? This would be 5/3, or 1 2/3. And then I have 0.4. I'll do that in yellow. So let's see, 0.4 is going to be less than 1. It's also going to be less than 0.5. I know 0.5 would be my half. So 0.4 would be about right here. All right, now I have 5 over 8. So 5 over 8 is going to be a little bit more than 1/2, right? Because 1/2 is equal to 4 over 8, and I want 5 over 8. So I'm going to go over here to my 1/2, and I'm going to go just a little bit above that. So it'd be about right here, 5 over 8. And so I completed this using a number line, but I do have these numbers from least to greatest, right? I have -2, and I have 0, 0.4, half, 5 over 8, 1, 1.1, 5 over 3, and then finally 2. All right. Final problem here. Find each sum. All right, so remember, we can add these fractions together once they have common denominators, right? Once the number on the bottom of the fractions are the same. And so when I look at 3 over 5 plus 1 over 3, I need to figure out what is the smallest number that both 5 and 3 go into. So I'm going to make a list here. 3, 6, 9, 12, 15, 18, 21. And now I'm going to make a list. That was for my 3's. And now I'm going to count by 5's here. So these are my multiples of 5. 5, 10, 15, 20, 25. And if I look through this, the first number I see up top that I also see on the bottom is 15. So this would be the least common multiple, we'd call it. All right, the smallest number that both 3 and 5 go into. So since I know that 5 and 3 both go into 15, I can make my fraction out of 15. All right, and so if we were going to transform 3 over 5 into a fraction over 15, I would have to multiply 5 by 3, and so I have to do the same thing to the top. And 3 times 3 is going to give me 9. And so this is going to be 9 over 15 plus, let's see what 1 over 3 would transform into. So here I have 1 over 3, and I'm setting it equal to a number over 15. And so I would have to multiply 3 times 5 to get to 15, so I do the same thing to the top. 1 times 5 is going to give me 5. And so I'm doing 9 over 15 plus 5 over 15, and that's going to give me the final answer of 14 over 15. And we can't simplify that, so we're going to keep that as is. All right, moving on to the next problem. It says 5 over 7 plus 1 over 2. So once again, I need to figure out what number 7 and 2 both go into. Well, 7, 14, 21, those are my multiples of 7. And then if I go multiples of 2, it'd be 2, 4, 6, 8, 10, 12. Oh, there's 14. That was one of my multiples of 7. It's also a multiple of 2. So 14 is my least common multiple, right? The number that both of those numbers go into. So now I'm going to make my fractions out of 14. 5 over 7, well, that would become 10 over 14, right? And I'd have to add that to 1 over 2, which would become 7 over 14. So now that I've transformed these fractions into fractions with common denominators, then I can just add the fraction together. So 10 plus 7 is going to be 17, and then we keep the denominators the same, right? We don't add those denominators on the bottom, and so we have 17 over 14 for our final fraction. But you'll notice that numerator is bigger, and so if we wanted to change that, we would say, okay, 17 goes into 14 one time, and there's 3 left over, right? So it'd be like 14 over 14 plus 3 over 14 to get to 17 over 14. So we could say this is 1, right? We could make this a 1. And 3/14 are left over. You see that? 1 and 3/14. So this here would be our final answer, 1 and 3/14. All right, now we have one more problem. How about it? This problem says 1/6 plus 2/8. All right, so what is the least common multiple for 6 and 8? 6, 12, 18, 24, 30. Now let's see if that's enough. Now we're going to put the multiples of 8, 8, 16, 24. Oh, there we go. So you'll notice 6 goes into 24, 1, 2, 3, 4 times. All right, and 8 goes into 24, 1, 2, 3 times. So knowing that goes into 24 4 times, and then 8 goes into 24 3 times. Then I can just do, to figure out my new numerators, I would do 1 times 4, because 6 goes into 24 4 times. So if I do 1 times 4, I get 4 up top. And then to figure out my numerator here for 2/8, 8 goes into 24 3 times. And so I can do 2 times 3, which gives me 6. So now I just do 4 plus 6 up top, keep my denominators the same. So my final answer would be 10/24. Can we simplify that? Yes, both numbers are divisible by 2. So I'd bring it down to 5/12. All right, so this would be the final answer for C, 5/12. Okay, so it looks like we're all good. Awesome, awesome, awesome. So use this as a resource. Hopefully this makes sense. It's kind of difficult to explain because you hear numerator, denominator, multiply this, multiply that, divide. So ask me if you need any clarification, but hopefully this helps.